हरि करना।
Now let's look into the various applications of this continuous random variables and their probability functions in machine learning. So you may ask, why not why not discrete random variable? So most of the cases, most of the examples we have taken so far using categories or discrete variables only. So discrete random variable related machine learning models, this kind of examples only we have taken. So we haven't discussed much, we haven't focused much on continuous random variable and their respective examples. So that's the reason we will be discussing continuous random variables and their probability functions usage in machine learning. Let's begin. So in machine learning, there are many examples of continuous random variables and their corresponding probability functions. One of them is a regression. A regression, that's what. Till now, we have dealt with classification, clustering, and segmentation, and and uh, sentimental analysis and these kind of things. So that's the reason I just want to have a quick applications of continuous random variables. So in a regression analysis, the output variable is a continuous random variable with a probability density function, so that depends on the input features and the choices of a regression algorithm. The probability function might be a Gaussian distribution with a mean and a variance that depend on the features or a mixture of Gaussians. Okay, so then we have neural networks. Neural networks are a popular type of machine learning model that can learn to represent a complex, high dimensional probability distributions. The output of a neural network can be seen as a continuous random variable with a probability density function that depends on the network architecture, activation functions, and training data. The probability function might be a mixture of Gaussians or a non-parametric distributions. Then we have a reinforcement learning. In reinforcement learning, the agent's actions are determined. The agent's actions are determined by a probability distribution over actions, which can be seen as continuous random variable. The probability density function depends on the policy function, which maps the agent's observations to a probability distribution over actions. So the probability function might be a Gaussian distribution with a mean and variance that depend on the state of the environment or a mixture of Gaussians. So these are just a few examples of many continuous random variables and their probability functions used in machine learning.